Okay, guys, this is part 2 of our lesson on solving equations. So we're going to look now at some word problems. And so to be able to do these, we've got to look at the story problem that's here, write our own equation from it, and then use that equation to solve for whatever the problem's asking us to find. Now, writing the equation is going to be a lot like writing the expressions were in our last lesson. The only difference here is that we're now going to have to look for something that would indicate an equal sign, because an equation is going to have an equal sign where an expression did not. So if there's a total in your problem, then you know that you're going to have an equal sign with a total behind it. If there's not a total, then we've got to kind of look for something else, some other relationship in the problem that shows when something is equal to something else. So this first one here says, Elena paid $26.50 for a shirt with sales tax of 6% included, but she doesn't remember the price without tax. What was the price of the shirt? So whatever the question's asking you for, that's going to represent your X. And then we're going to have to figure out kind of what the rest of this is telling us. So it tells us she paid $26.50 for a shirt with tax included, but she doesn't remember the price without. So we know that if the tax has already been included with the price of the shirt, that's a total. So when I go to write this equation, to have an equation that equals $26.50 would make sense, because $26.50 is the total that she paid. Now, the $26.50 that she paid was for a shirt and for tax on the shirt, because it says the $26.50 is what she paid for a shirt with sales tax included. So that means that we can create an equation that shows us with the price of a shirt plus the tax on the shirt to get to that $26.50. Since we don't know the price of the shirt, we're going to let that be X. The tax is 6%. So if you remember when we did expressions, we talked about how if we have a percent, we do two things. First, we change it to a decimal. So 6% as a decimal becomes 0.06. We move the decimal twice to the left. And then also in an equation, the percent always gets the variable. There's always multiplication of the percent by the variable. So we have X as the price of the shirt plus 6% of X, 6% of the shirt, to give a total of $26.50. And that's the equation we're going to solve. So it's a really simple equation. Remember, this X by itself is 1. So 1 plus 0.06 will give us 1.06x. 26.50 comes down. And then to solve that, we just divide by 1.06. And so X will equal $25. So we've written that equation and we've solved it using our normal steps to get to an answer of 25. All right, similar question about Emma buying a blouse. So Emma bought a blouse on sale for 20% off the regular price. The sale price was $28.76. What was the regular price? Write an equation and then solve it. So looking at this, she bought a blouse on sale for 20% off the regular price. Sale price was $28.76. So that tells me that this is what she actually paid for it. She bought one on sale for 20% off the regular price. And we're trying to find regular price. So regular price is going to be X. We've got to be able to show 20% off of that regular price to equal what she actually paid. So it's going to equal $28.76. Because that's the total she actually paid. Now, this is a little bit different than the last one. The last one, we had the cost of the shirt plus tax on the shirt to get the total with tax included. Now we're trying to get the sale price with the 20% off included. But 20% off indicates that we're going to be subtracting because we're decreasing the price of it. So the original price of the shirt minus 20%. So again, it's a percentage, so we've got to change it to a decimal, 0.20. And then it always gets the X. So 0.20x. And then, again, we're going to solve that exactly the same way we just did. 1 minus 0.20x is 0.80x. This is still 28.76. And then we'll divide both sides by 0.80. And we're going to get $35.95. Okay. All right, here we have another problem that we're going to write an equation and then solve. At 12 noon in Anchorage, Alaska, Henry noticed that the temperature outside was 12 degrees. The temperature dropped at a steady rate of 2 degrees per hour. At what time was the temperature negative 4 degrees? So let's look at all the information they give us. It was 12 noon, and the temperature was 12 degrees. It dropped at a rate of 2 degrees per hour. And they want to know at what time the temperature reaches negative 4 degrees. So since we're trying to figure out when the temperature will be negative 4, that's what we want our equal sign to equal, because that's what we're trying to reach. When does it equal negative 4? So let's look at what's happening with the temperature. At 12 noon, it was 12 degrees, and it's dropping at 2 degrees an hour. So I need to, since the whole thing is involving temperature, the time itself doesn't actually matter. Like that 12 noon doesn't really make any difference. But the fact that it started at 12 and it dropped 2 degrees every hour means that I need to start at 12 and subtract 2 for every hour that passes by. And so with that, I'm going to split the world and solve it. So I would subtract 12. And you might look at this and say, I can figure this out without an equation. Yes, you absolutely could. This is not a difficult problem. However, if they ask you to model it with an equation, I need you to be able to do that. And we get 8 hours. Now, the question itself actually asked at what time. So 8 is the number of hours that would have passed. It took 8 hours to reach that temperature. So if it started at 12 noon, at 12 degrees, and 8 hours later it hits negative 4, you've got to think, well, what time is it if it's 8 hours after 12 noon? And that would be 8 o'clock p.m. So, for example, if the question had said something about at 6 a.m. in Anchorage, Alaska, the temperature was 12 degrees and it dropped 2 degrees an hour, you would have to figure out what 8 hours after 6 o'clock was to be able to figure out your time. So this one happened to be at 12 noon, and so it ended up being 8 o'clock at night, but that's not because the H equaled 8. It's because 8 hours after 12 noon is 8 o'clock. All right, let's keep going. Elijah's bowling score is 5 less than 3 times Isaiah's score. The sum of their scores is 215. Find the score of each student. So Elijah is 5 less than 3 times Isaiah. The sum is 215. And we're trying to find both students' scores. Now, we can't solve an equation with 2 different variables in it. So I can't say E plus I equals 215 and be able to solve that. Because there's no way to solve it in that form. Although this does say the sum of them, Elijah plus Isaiah would equal 215. But I can't solve it the way that it's written. So what I need to do is figure out algebraically how can I show Elijah's and Isaiah's scores using the same variable and then be able to create that equal to 215. So let's read what it tells us about Elijah and Isaiah and see if we can figure out how to do that. So up here it says Elijah's score is 5 less than 3 times Isaiah's score. Well, we know how to do 5 less than 3 times something else. We don't know Isaiah's score, but we know how to show 5 less than 3 times that. If we let Isaiah be x, 3 times x minus 5. That'd be 5 less than 3 times Isaiah. So I'm going to use that in place of Elijah over here. 3x minus 5. 5 less than 3 times Isaiah. Which means for Isaiah, I can just put a plain x. Because if this 3x represents 3 times Isaiah, then this x could be just Isaiah by himself. So Elijah plus Isaiah equals 215. And I'm going to solve that. So to solve that, first thing I need to do is combine terms. So I have a 3x with an x. So I really end up with 4x minus 5. And And I can add that 5 to cancel it. And then divide both sides by 4. So I get that x is 55. Now, what did x represent again? You got to think about that. X is 55. X, remember, was Isaiah by himself. So that means if we're answering this question, Isaiah had a score of 55. Elijah would have had a score of what? How do we figure out Elijah's score? A couple of ways you could do that. You could take that 55, that is x. Oops, I didn't mean to move that. And plug it in for x up here in Elijah's expression. So 3 times 55 minus 5. And that will give you Elijah's score. Or because you know the two of them together is 215, if his is 55, you can subtract that from 215 to get back to Elijah's. That's probably the easier option. But it doesn't matter to me which one you do. But we know Isaiah is 55. So I would have done 215 minus 55, and that gives me Elijah's score at 160. Oops. So those are really the two answers to this question. We use this equation to find those two answers. All right, let's look at one about Piper and Kate. Piper has saved twice the number of quarters that Kate saved plus 6. The number of quarters Piper saved is also 5 times the difference of the number of quarters Kate saved and 3. Write and solve an equation to find the number of quarters each person has saved. So this problem is a little bit different because it doesn't give me a total number of quarters the girls have. The problem before this gave me all kind of mathy things like that, but it gave me a total for the two fellas. This one does not give me a total for Piper and Kate together. What it does do, though, is tells me that Piper has this many, and then it also tells me that Piper has this many. Now, if you think about it, and this is just kind of a roundabout way of looking at it. If you had, and don't draw this, I just want you to think for a minute. If you had 5 quarters, you could choose to arrange those quarters in a set of 1 and a set of 4, or a set of 2 and a set of 3. And you still have the same number of quarters no matter how you choose to describe the arrangement of them. Whether you put 1 and 4 together or 2 and 3 together, it's still 5 quarters total. So the way this problem is set up is kind of similar to that, where they describe what Piper has in 2 different ways. But both descriptions are still Piper, which means the 2 descriptions can be equal to each other because they're both describing the same thing. So that means I can create an equation where what the first sentence says is equal to what the second sentence says. And then I can solve that for what's missing. So the first sentence says Piper has twice the number of quarters Kate has plus 6. So that's going to look like 2 times Kate plus 6. The second sentence says Piper has 5 times the difference of the quarters Kate has in 3. So 5 times a difference. Difference means to subtract. So to show 5 times something subtracted, I've got to use some parentheses. So difference of Kate and 3. And so there's an equation I can solve. The first sentence equal to the second sentence because both sentences describe what Piper has. Now when I solve this, I'm going to get the value of K. And remember, K represented the number of quarters Kate had because she was mentioned in both of these descriptions. So we're going to solve it and get Kate, and then we'll be able to use that to get Piper. So let's work on this. We got to distribute 5K minus 15. And then we're going to subtract 5K, subtract 6, and we get negative 3K and negative 21, and divide both sides by negative 3, and K is 7. So that means Kate has 7 quarters. So to figure out what Piper has, I've got to take this idea that Kate's got 7 and think about it in terms of what the sentences say. So I can either put it in right here for Kate having 7, or put it in here as Kate having 7, and then simplify one of those two expressions, or evaluate one of those two expressions. So I'm going to just go here with it. 2 times 7 would be 14, plus 6 gives 20. So that tells me that Piper has 20 quarters. I also could have plugged it in on the other side and done 7 minus 3 and got 4. And 5 times 4 is 20. So if I put it here, 7 minus 3 would be 4. 5 times 4 would be 20. So either way works, but you've got to be able to come up with both if they ask you for how many both have done. All right, we're going to do one more together and then let y'all try a couple. Oops. There we go. This says 1 month, Nola worked 3 hours less than Leah, and Michaela worked 4 hours more than Leah. Together they worked 196 hours. Find the number of hours each person worked. So this one does give us a total. This one is a lot like the one about the bowling scores for the two fellas. This actually got 3 people in it this time, but same idea. So if together they've worked 196 hours, I know that what I create needs to equal 196. But this is 3 people together, so I've got to have something for Nola, something for Leah, something for Michaela to equal that total of 196 hours. So I'm going to think, okay, Nola, Leah, Michaela. So it describes everything in terms of what Leah has. We don't know anything about Leah. They don't give us a statement for hers. So we're going to let Leah be plain X. Or you can put L if you wanted to. And then for Nola to work 3 hours less than Leah, less than means to subtract. So X minus 3. And Michaela works 4 hours more than Leah. So X plus 4. And together that all has to come and be 196. So I can solve this little equation. Combine our terms. Negative 3 plus 4 is positive 1. So I'll subtract the 1. Divide by 3. So X is going to equal 65. So if you remember, we said X was Leah by herself. So Leah has 65 hours. So to figure out Nola and Michaela, we take that 65 and we relate it to what it said about that. So it said Nola was 3 less than Leah, so we do 65 minus 3, so Nola is 62. It said Michaela is 4 more than Leah, so we do 65 plus 4, Michaela was 69. And so if you wanted to check and make sure you didn't mess that up, you could add those 3 together and you come back to that 196, and you know you're correct with all of that. So I'd like you to take a minute, pause this video, and work this problem about Charles and the problem on the next slide about me. But look, on that one on the next slide, you're going to have to change it from 28 people to 26 people because I made a mistake on it. So go to the next slide. I can't click over there. It'll interrupt my video and be weird. But go to the next slide and change that 28 people to 26 people. And then work this one about Charles and the one about me. And then unpause it and see if you get the correct answer. Now, I'm going to give you a little bit of a hint on this one about Charles. Number one, it comes out to be a weird decimal. Just round it to the nearest whole number. Secondly, it talks about profit. So remember that profit is the money you make after you subtract the money you spend on something. So if I was going to sell somebody a cake, I would bake the cake and calculate how much money it cost me to make it. and then subtract that from what I sell it for, and that tells me how much profit I have. So when you're working on this question about license plates, consider how much money they sell them for and how much money it costs them to make them, and figure out from there how much they actually earn in profit so you can create the correct equation. So pause the video, see if you can figure that out, set that up, and then unpause it and see if you were correct. All right, take a look at this and see if you got this correct. So you had to subtract what you sell them for and what you spend to make them to get the left side of the equation. And then the right side was the total of your expenses. Because if you can find the point when those things are equal, you'll know how many you would need to sell to be able to make a profit. So when you work all that out, you get 1,583.09 license plates. If they want to know how many plates must be sold to make a profit, this would let you break even, like make the same amount that you spend. So in order to make a profit, you need to sell one more license plate. So if this was like a multiple choice type answer, you would want to pick 1,584 license plates, because one more would allow you to make profit, where this many, 1,583, would let you break even. You would spend and make the same amount of money. So 1,584 plates is really the correct answer to that. And then the second one, you should have gotten 10 people in one group and 16 people in the other. And this would have been your equation for that. 4 less than twice as many would be 2x minus 4. The other group would have just been plain x. Together they made 26 people. And so 10 in one and 16 in the other would allow that to be true. All right, there's a few more slides on here of test prep questions, and so we're going to look at those, but I want you to look at those, and I want to show you how Desmos can be useful for you in saving some time and solving some of these. So you folks that are not used to Desmos, Desmos is a graphing calculator tool that is an app on your iPad, and you'll be able to use it on your state test, and it allows you to graph some things and see solutions to some of these equations without having to spend the time it takes to work them. So we're going to look at some that we might can use Desmos on and some we can't, but we'll look at what this might look like on your state test. So this question almost always shows up. They like to put questions like this where they give you lots of long drawn out equations and answer choices, and you've got to be able to tell which answer matches up with which one. So you can work all 4 of these by hand. It'll take some time, but it is entirely possible to do that. But you also have the option on things like this of being able to work them in Desmos. So I'm going to show that to you. I can't pull up my app and let y'all see it, but I can pull it up in this little screen here. So, I don't know if I can move this around either. Yeah, I can, okay. So if I wanted to use Desmos to solve these instead of having to work them out by hand, you can do that, but the way we do it is we put what's on one side of the equal sign in one line of Desmos. What's on the other side of the equal sign is a separate line, and then we look for their point of intersection. And the x value where they intersect tells me the solution for that particular equation. So I'm going to try that. So negative 7x minus 12. And then negative 7x. Oh my gosh. Plus 3. Negative 4. Minus x. Sorry. Minus x. Okay, so we get that. And I realized it probably took me longer to type that in than it would have taken me to work it by hand, but whatever. So I'm looking for, I'm zooming in and out by pinching, the point where those 2 lines cross. So notice that it graphs the first side in red and the second side of the equation in blue. And so if I can find the point where they intersect, that's going to tell me where they're equal. It's going to tell me where their solution would be. And so I can tap kind of near where that point is, and it shows me a dot. And they intersect at 0, negative 12. The x part of that point is the solution to that. So that means the solution to this is that x will equal 0. And so I can do the same thing with the next one. Sorry, y'all. Maybe. There we go. So I can graph 4 times 2x plus 3. Too many parentheses, sorry. And then 5x plus 3x minus 6. Okay, and so here's what I've got. Notice that these lines are parallel. They never touch each other. Okay, they never get any closer together, so they're never ever going to touch because they're parallel. So remember, lines that never touch can't have a point of intersection. They can't have a solution because they will never be equal. So the second one has an answer of no solution. So take a minute, pause the video and see if you can graph the next two and come up with a solution for them. And then unpause it and see if you were correct. Please actually pause the video and try them. Okay, we're back. So if you tried these yourself and you worked them out, you should have gotten that the first one is -4 and the last one is infinite solutions. And the reason we know that last one is infinite is because it shows the same line overlapping everywhere. So since every point overlaps, we know that there's an infinite number of solutions because it touches in every possible point. So that's one way we can use Desmos to help solve some of these equation problems. Let's look at a couple more. So here's another one that you could use Desmos to solve this, or you could choose to solve it by hand. Honestly, it probably takes longer to put this in Desmos than it does to try it by hand, but if you'd like to do it in Desmos, you can. Or you can take a moment and solve it by hand. But if you'll pause the video, come up with an answer, and then unpause it and see if you were correct, that'd be great. Okay, so you should have gotten an answer of 7, E, positive 7. Again, if you did it in Desmos, you graphed this on one side, this on the other side, found their point of intersection, and reported the x value from that point. The y does not matter, just the x. All right, this is one that could be on the test. There are lots of questions like this that show up on state test practice, but you will not be able to use Desmos for one like this one. So you've got to know the steps to how to solve an equation to be able to do this. So they ask you, if Jasmine wanted to solve this equation, what would be her first step? Now, if you were looking at that and you were going to solve it the way I have taught you to solve it, you would automatically say distribute the 3 first. And so we know for sure that answer E is correct because it says distribute the 3. But they ask us to come up with 2 answer choices. So that means there must be one more thing here that mathematically can work. So we want to look at our choices and see what they're asking us to do and see if it makes sense mathematically. A says to divide both sides of the equation by 3. So remember, when you're solving an equation, you're using inverse operations to do that. So you have to go and decide if division by 3 would be the inverse of whatever's already happening to the 3. So if you look at the equation up here, the 3 is here. It's being multiplied by what's over here. Division is the opposite of multiplication. So let's look at the rest of it and see if this would actually happen. If I divided everything on the left side by 3, 9 would become a 3, 12 would become a 4. If I divided over here by 3, this 3 would cancel with the 3 I'm dividing and leave me with x minus 8. So this is actually correct. So A and E are our correct answers here. If you want to look at your other answer choices and see why they're wrong, B says to divide both sides by 12. 12 is being added, so division is not its inverse. C says subtract 3 from both sides. 3 is being multiplied, so subtraction is not its inverse. D says subtract both sides by 12. Now, subtraction is the inverse of addition. So D looks like it could possibly be reasonable. But if you notice how when they do their subtraction, they subtract it from what's in parentheses, you can't do that. You can't just put something else inside the parentheses that's not already there. Parentheses are their own thing, and you can't add or subtract inside of them. So that's going to be a no as well because of that. Mathematically, that does not work. So A and E. All right, one more. Try this one in Desmos or try it by hand, either one. See if you can come up with an answer. Pause the video and then come back and see if you were correct. Okay, so if you have paused it, worked it, and come back, you should have gotten an answer of E. Correct answer here was 2. All right, and that is the end of that second day's lesson. You should be ready to do the graded practice on solving equations by this point and all that. Y'all have a wonderful day.